everyone, this is Harry from the H2O Club. In this video, we'll prepare for our AP Chemistry related experiment for Semester 1 on electrolysis. By the end of this video, you'll understand the key background concepts and know what to do for the experiment. These are the table of contents, and I'll start with the alignment with AP Chemistry. This is how the experiment will connect to the AP Chemistry curriculum. From Unit 9, it'll be topics 9.8 and 9.11, which are about electrolytic cells and electrolysis. And this experiment also connects to Unit 8, acids and bases, specifically on topics 8.1, 8.2, and 8.4. But the majority of the concepts will be connected to Unit 9. And the knowledge needed from Unit 8 will be pretty basic. Okay, now I'll go into background knowledge. Let's start with the big picture. Some reactions happen naturally, for example, a candle burning, but some reactions only happen if we give them extra energy. And electrolysis is when we use electricity as that energy source to drive a chemical change. And for the reactions that happens on their own, we call them spontaneous reactions. And for the reactions that only happen if we force them to happen or like put in extra energy, those are called non-spontaneous. In electrolysis, we place 2 electrodes into a solution. Electrodes are just conductors placed in a solution that allows electricity to enter and leave the solution. You can think of the battery as an electron pump, and the anode on the left side of this image is the positive side. Here, oxidation happens, which means that particles lose electrons. And on the right side, it's the cathode, which is the negative side. Here, reduction happens, which means that particles gain electrons. Now you might wonder, how is it different from a battery in your phone? So in a galvanic or voltaic cell, like a normal battery, the reaction happens on its own. Again, that is called spontaneous, and it releases energy that can power a device. So examples of these will be batteries, phone batteries, AA batteries, and etc. In electrolytic cells, however, the reaction does not happen on its own. Again, that is called non-spontaneous. Here we have to push it forward by supplying electricity. So an example of this will be water splitting. So we can split water into hydrogen and oxygen by using electricity. And the lab that we are going to do will also be an electrolytic cell. So basically, galvanic cells give us energy, and electrolytic cells use energy to make chemical changes. For ions in solution, when salts dissolve in water, they form something called ions, which are charged particles that can move around. There are 2 types of ions, which are cations and anions. Cations are positive ions that move toward the cathode, which is the negative electrode. And anions are negative ions that move towards the anode, which is the positive electrode. So examples of these will be Na+, which is cation, and SO4 2-, which is an anion. Also, this movement of ions is what allows electricity to pass through the liquid. And the movement of ions conduct electricity. Okay, this is like a basic part of acids, bases, and pH. There's a lot more concepts, especially in AP Chemistry, that you'll have to know. But for this demonstration, those are not necessary, so let's just recall the basics of pH. An acidic solution has more H plus ions with pH less than 7. An example would be lemon juice. And a basic solution has more OH minus ions with pH greater than 7. And an example would be soap. And the neutral solution, as you can know from the name, it has a balance of H plus and OH minus with pH equal to 7, like pure water. This is the pH scale. You all probably saw it once. pH less than 7 would be acids, and pH more than 7 would be base, and when the pH is exactly 7, it will be neutral. And indicators are solutions that show these changes with colors. So here, if the solution becomes red, you'll know that it's a really strong acid. Okay, now I'll talk about the experiment that we'll do. Our purpose is to use electricity to drive a chemical reaction in solution. So we'll observe what happens at the anode and the cathode and record the changes we see using the concepts of ions, pH, acidic, basic, and indicators. So what you will do in the lab, in simple terms, will be to set up the electrodes, which will be the pencil leads in this case. So as you can see here, and connect them to a battery, and then you'll see what happens at each electrode, so the left side and the right side, and you'll record what you see. Just so you know what happens in the experiment, you'll probably see some kind of color change in each end of the electrode. So that was it for the experiment. We'll post a detailed procedure for you to follow on the lab day, and your focus will be to make clear observations and then explaining them with the vocab we reviewed. Thank you for watching.